Welcome back to Lane's ED enhancement. Our last video, we looked at realistic scenarios part 2. Now today we are going to look at the big one, part 3. So today again we'll be going through an example from seaborne cargo and dangerous goods. We will be looking at the efficient packing of small cartons into a container to maximize the capacity of that container. Now, this is a typical example of what takes place at some manufacturing production depots. Here, we are given a container of a particular dimension, and we are also given some cartons of a smaller dimension to be packed into it. We are also given specific instructions in A and how we are supposed to pack these cartons into the container. B, we also have been advised to continue packing them, so we are given another aspect, another way in which we are supposed to pack. Now for part B, we are going to show part B, work that in a video called part 3B. As this is part 3A, you can assume that we will be working part A. It doesn't stop there. We are also asked to solve a part C where we want to get as many more cartons into the container based on a certain packing arrangement. There's also D, where we work out volume usage for the packing arrangements A, B, and if there is one for C. And also, we're going to be looking at the unused space for these packing arrangements. C can be seen in video part 3C. Let us look at the solution. Now, since the given container is in meters, we will also convert the dimension of the cartons into meters. As you know, it is much easier to work in the larger unit. So we were told that the width of the carton is 250 millimeters, and since 1000 millimeters equal 1 meter, then we will divide this 250 millimeter by 1000 and we get 0.25 meters. For the length, it is 400 millimeters. We also divide that by 1000 to get 0.4 meters. For the height, it is 150 millimeters. We divide again by 1000 and we get 0.15 meters. Now let us look at the given container dimension. Width is 2.4 meters. The length is 5.9 meters. And the height is 2.35 meters. Note the length of the cartons and the width of the container have been highlighted. Now let's see why. The highlighted information on the previous slide is our first packing instructions. Now, A asks us, how many cartons can be packed with the longer side of each carton across the width of the container and with all layers packed right way up? Now, there's a video that I'd like you to up over after you have finished going through this, which is going to give you some more detailed explanation of this particular packing instruction. It is called diagram 1A and 1B. Now, let us explain a little of what A means. They instruct us to pack inside of the container. We are going to pack the cartons across the width. Now, the width of the container is going to be there, and also when we look at packing these cartons, the length of the cartons will go against the width of the container. Now, after you have looked at the video, you will get a clearer perspective on this. But for now, let us express this mathematically. Now, based on the instructions in A, we realize that across the width of the container would be the width of the container, and when you're packing the cartons, the length, it would be divided by the length to determine the number of cartons that can go across the width. Therefore, given the width of the container 2.4, we will divide by the length of the carton 0.4 and we get 6. It is good to work out if there's any space, and so we have this section which we call leaving, which is just for the remainder. So we have leaving 2.4 minus 6 times 0.4, which is the length of each carton, and we get 2.4, which is equal to 0. So there is no space. That means everything that is packed across the width of the container is packed solid. Now, when the width of the container is placed with the length of the carton against it, we realize that the height of the cartons will be resting against the height of the container. Therefore, we realize that across, when we look at the height now, we look at across the width, we're going to look at the height. The height of the container would be divided by the height of the carton because the cartons are resting with their height against the height of the container. This means the height of the container, which is 2.35, divided by the height of the carton, which is 0.15, and we get 15 point something. We don't want to use the remainder. So what we do, we work out what that is. So 15 times the height of 1, which is 0.15, gives us 2.25. And we will take away the 2.25 from 2.35, and the remainder is 0.1. That means there is just 0.1 of a meter remaining on the height of the container. Now, we see where the width of the container has been used. The height of the container has been used. We don't see where the length of the container has been used. And we see where the length of the carton has been used and the height of the carton has been used, and we don't see where the width of the carton has been used. Therefore, the width of the carton will be placed against the length of the container. Therefore, the length of the container will be divided by the width of the carton. which is length of container 5.9 meters divided by 0.25 meters, which gives us 23 with a remainder. When we work out what 23 of the width of this container would be, we get 23 times 0.25, which gives us 5.75. When we take that away from 5.9, we are left with 0.15. Very good. Now to determine the total number of cartons that are packed into the container, we will multiply only the whole numbers. So we have 6 across the width times 15 on the height, and we have 23 on the length. That gives us 2,070 cartons packed as per the instructions in A. So that would take care of part A. So see you on the next episode of Realistic Scenarios, part 3B, for the continuation of this question. Now remember to like, share, and subscribe to this channel and hit the notification bell to know when the next episode is available. We look forward to your comments, as this will definitely help us going forward. Thank you.